want to take a look at a couple more trig integral rules. We saw how we can use that identity sine squared x plus cosine squared x equals 1 to substitute in. We would use that rule when we have something with an odd exponent. If it was sine to the fifth x, cosine squared x or something like that. But this will help deal with something when you have an even exponent in here. So there are these two trig identities that you do need to know. So hopefully you can read the top here. It's sine squared x equals 1 minus cosine 2x over 2, and cosine squared x equals 1 plus cosine 2x over 2. So I'm not a big fan of memorizing, but you definitely do need to have these memorized if you do expect to know how to do these when a test or quiz comes around or anything like that. So, how you do this, so let's say we're trying to integrate cosine squared x. So again, this is something we couldn't have integrated last year without utilizing this, this trig identity here. So I'm just going to go ahead, since cosine squared x is equal to that, I'm going to substitute, the 1 plus cosine 2x over 2 in for cosine squared, and we'll see how that'll make our life a lot easier. 1 plus cosine 2x over 2 dx, so I've just substituted it in. And now the only thing I'm going to do before I integrate is deal with this 2 on the bottom. A couple ways you could do this. You could divide it into each term individually, or you could just bring it outside completely, which I'll do. So I'll bring a 1/2 out in front of the integral. You can bring constants outside the integral, not variables. And then it leaves me with 1 plus cosine 2x dx. Well, now that's something that I can integrate right away. So this would be 1/2 times, I'll put this all in parentheses, so the antiderivative of 1 is just x. The antiderivative of cosine is sine. I notice the derivative of my inner function is just a number. My inner function is 2x, so if I take the derivative, that's 2. So then I can just go ahead and divide by that number. So we have cosine of 2x, so the derivative of that, or antiderivative of that is sine. So it's going to be plus sine, keep my inner function the same, and then I'm going to divide by that inner function of 2x. If that's a weird thing for you, you can use substitution to, integrate cosine 2x. But it is nice to be able to just do that when the derivative of the inner function is a constant, to just divide by whatever that derivative is. Okay. So that's it. I could distribute my 1/2 if I wanted to make it 1/2 x plus 1/4 sine of 2x, but that's it. Let me look at one more here. Let's say we have sine to the 4th of 3x. How about? Well, in this case, we're going to need to use this trig identity, but we're going to need to split this up into sine squared 3x times sine squared 3x. And you notice there's a little difference here. Instead of it just being an x in there, it's now a 3x. So when I go to this trig identity here it says sine squared of x, and with the thing I'm going to replace it with is all of this with the cosine of 2 times x. So essentially it's 2 times whatever x is. So in this case, our thing in the place where x is 3x, so therefore this is going to be 2 times that value, so it will end up being 6x when we replace it. So let me go and replace that, and it's going to be 1 minus cosine of 6x over 2 times 1 minus cosine 6x over 2. Okay, so again, all I did was replace sine squared 3x using this trig identity with both of those. So let me see, this 2 on the bottom, let me go and take that out here. So it's going to be a 1/4 on the outside, because it's 2 times 2 on the bottom is 4, times the integral of. Now I'm going to go ahead and I'm going to distribute out on the top here. So I'll multiply 1 times 1 is just 1. When I multiply 1 times negative cosine 6x, and again 1 times negative cosine 6x, it'll be minus 2 cosine 6x. And then it will be, when I multiply those guys together, it's going to be a negative times a negative will be a positive cosine squared 6x. Okay. Now, this guy's good to integrate, this guy's good to integrate, this one, not so much. I need to replace it one more time with this over here, okay? So I need to be careful with this. let's see, I'll go up here and do that. So it's going to be the 1/4 I'll keep outside, my integral, times the integral of, the first couple terms are going to stay the same, 1 minus 2 cosine of 6x. And then instead of writing cosine squared of 6x, I'm going to replace it here, and again, same idea. Here it's x, well here in place of x it's 6x. So where this is 2 times x, now this will be 2 times 6x, or it will be 12x. So I'm going to place that, where I see this, it will be plus 1 plus cosine 12x over 2. Okay, one last step before I do the antiderivative. Now, unfortunately in this case I can't just divide a 2 out of this without, affecting these other terms here. So, I could, I guess, somehow factor that in, but instead I'll just divide 2 into each of these individually. So it'll be 1/4 times the integral of 1 minus 2 cosine 6x plus, so I'm going to divide 2 into the 1, so it'll be a half. Divide 2 into the cosine, so that'll be just 1/2 cosine 12x. That's a 12x, by the way, kind of hard to read. There. Alright. Alright, and my last thing, I guess I could simplify, and I'm just going to cheat here since I have a whiteboard and I can erase. This 1/2 and the 1 are like terms, so I can combine those together to be 3/2. I'll just erase this. So again, there was a 1 here, there was a 1/2 here, add them together, that's just 3/2. But now I'm ready to do the antiderivatives. The antiderivative, the 1/4 stays in front, the antiderivative of 3/2 is just 3/2 x. The antiderivative of, there's 2 cosines, remember, antiderivative of cosine is sine. The derivative of the center function is 6, so I'll just end up dividing by that. So it's going to be minus 2 sine of 6x, and then I just divide that by 6. So I could simplify that to 1/3 if I wanted to. Plus, and then the same idea goes here, antiderivative of cosine is sine, so it'll be 1/2 sine of 12x. But then since the derivative of that inner function is 12, just a number, it only works when it's a number, I can just divide by that. And so that will end up being, when I divide by that, it's going to end up making this 1/24 right here. Because I'm having 1/2 divided by a 12th, which is just 1/24. And then my plus c. And again, I could, if I wanted to here, expand this out by multiplying the 1/4 by each term. This would just make this first term 3/8 and so forth. But it's going to be the same thing.